Hi folks, happy Wednesday. Today's target is to be able to convert grams, liters, moles, and particles into each other in two-step problems. If you haven't already, make sure you watch yesterday's video because yesterday's video was being able to convert grams, liters, moles, and particles in one-step problems. And you need to be able to do one-step problems before you can do two-step problems. To quickly review, yesterday we talked about this thing called the mole map, which is basically a map showing us how to convert grams into moles and moles into grams, moles into liters and liters into moles, and moles into particles and particles into moles. Those were what we call one-step problems. We were going from one part of the mole map to an adjacent part of the mole map. But what if I told you how many grams of a substance we have, and I wanted to know how many particles of that substance we had? That would be a two-step problem. The first step would involve going from grams to moles, and the second step would involve going from moles to particles. 2 steps. So we're going to go through 3 different practice problems today that kind of help us see how to do two-step problems and what are some common mistakes that people make while doing these problems. Alright, so for this first practice example, let's say we've got 42 grams of MgCl2. Remember folks, anything that I write down on the whiteboard, I want you to write down in your notes. So take a little bit of time, write today's target, write the mole map, and write down the practice problems that we're about to do. Alright, so we've got 42 grams of MgCl2, and we need to figure out how to convert it from grams to moles, and ultimately from moles to particles. Okay, so how do we do that? Well, in order to convert something from grams to moles, we need to use the molar mass. So how do we find the molar mass of MgCl2? We're going to use our periodic tables. Hey! So, on our handy-dandy periodic tables, we can use the atomic mass of magnesium, which is 24.3 grams per mole, and we can use the atomic mass of chlorine, which is 35.45 grams per mole. We know there's 1 magnesium atom in MgCl2. And we know there are 2 chlorine atoms in MgCl2. So what we can do is we can add the atomic masses of magnesium and the 2 chlorine atoms together to get the molar mass of the entire molecule. When I do that, I should end up getting 95.2 grams per mole. I'm going to write that up here, 95.2 grams per mole. Sweet. All right, now that I've got my molar mass, I can convert from grams to moles. How? How can I convert from grams to moles? Let's go over it. So let's say we've got 42 grams of MgCl2, that's our given. We're always going to start off with our given. We're going to multiply that by our conversion factor to get the number of moles. Alright, so which number goes on top and which number goes on bottom? Well, remember, I need my grams to cancel out. So my 95.2 grams is going to go on the bottom. MgCl2, we can add that as well, and that'll cancel out. Okay. However, we're also told that in 95.2 grams of MgCl2, there is 1 mole. And so we can put 1 mole of MgCl2 on the top. All right, so 42 times 1 divided by 95.2 is going to end up equaling 0.441 moles. So we're halfway there. We've done half of our two-step problem. Now, how do I convert my moles into particles? Let's go over it. So we know that we've got 0.441 moles of MgCl2. Cool. What I need to do is I need to use Avogadro's number to convert my moles to particles. You might remember that there are 6.02 times 10 to the 23rd particles in 1 mole. So what I can do is I can use this conversion factor to convert moles to particles. 1 mole has to go on the bottom. And Avogadro's number of particles has to go on the top. Why? Why does the particles need to go on the top? Why did the number of moles need to go on the bottom? Because my moles need to cancel out. Moles divided by moles equals 1. And so they go away, and I'm left with units of particles of MgCl2. Cool. When I plug these numbers into my calculator, I should get 2.65 times 10 to the power of 23 particles of MgCl2. Cool. So that's our first problem. We're going to go over 2 others. In the second problem, we're going to talk about how we convert particles to liters. Alrighty folks, let's go over this second problem. So our given, this time the number that we're given, is 4.2 times 10 to the 23rd particles of Br2. And we want to convert this into liters of Br2. Alright, so let's look at our mole map. We are starting with particles and we need to get to liters. So we're going to need to convert particles into moles, and then we're going to need to convert moles into liters. Alright, let's go over that and figure out how we're going to do it. So first things first, we know that there is 6.02 times 10 to the 23rd particles in 1 mole. I can use this conversion factor to convert my particles of Br2 into moles of Br2. What I'll do is I will start with my given, 4.2 times 10 to the 23rd. I'm going to abbreviate particles as part, just to save room. Particles of Br2 times what? What number goes on top? What number goes on bottom? 6.02 times 10 to the 23rd particles of Br2 should go on the bottom, and 1 mole of Br2 should go on the top. Once again, this is because we need our particles of Br2 to cancel out, so that we're left with units that are moles of Br2. The biggest mistake that people make in this entire unit is an order of operations mistake. Whenever you're dividing something by Avogadro's number, or you're dividing something that is in scientific notation, some calculators are not programmed to properly do order of operations. And since I don't know what calculator you're using to do these problems, I don't know if your calculator does it properly. The easy way to make sure that all calculators do it correctly is to put this number in parentheses. So when you plug the number into your calculator, put in 4.2 times 10 to the 23rd, you can do the times 1 if that helps you, and then divided by parentheses 6.02 times 10 to the 23rd, close parentheses. This is a very crucial thing that a lot of calculators get wrong, so make sure you're adding those parentheses just to be safe. Okay, when you do punch those numbers into the calculator, you should get 0.698 moles of Br2. All right, halfway there. we're at our moles. Now we just need to convert moles into liters. Okay, so how do we do that? How do we convert moles into liters? In order to convert moles into liters, we have to use something called the molar volume. So the molar volume states that there are 22.4 liters of a gas in 1 mole of that gas. And it just so happens that bromine gas is a gas. So we can convert the moles of bromine into the liters of bromine using our conversion factor. How? Well, if we put 1 mole of Br2 on the bottom and 22.4 liters of Br2 on the top, our moles of Br2 are going to cancel out, leaving us with the units liters of Br2. So 0.698 times 22.4 liters of Br2 is going to equal 15.6 liters of Br2. Congratulations, we have now solved our second problem. One more to go. We're going to convert liters to grams. So in this third practice problem, we've got 18 liters of H2O. And we're going to convert those liters of H2O into moles, and then we're going to convert them into grams. Let's go over how we do that. Okay, so first things first, I need to convert my liters into moles. Remember, our molar volume states that 22.4 liters of a gas is equal to 1 mole of that gas. And this happens to be water vapor, so it is a gas. All right. So if we've got 18 liters of H2O, how do we convert it into moles? Well, simply put, we are going to divide it by 22.4 liters and multiply it by 1 mole. Okay, so our liters of H2O are going to cancel out, and we're going to be left with moles of H2O. When I do that, I should end up getting about 0.804 moles of H2O. Cool. So now that I've got the moles, I need to convert to grams. What do I need in order to convert moles into grams? I'm going to need the molar mass. So that means we're going to need to find the molar mass of H2O. This is something that we've already done once in this video. Can you calculate the molar mass of H2O? Let's see if you're right. So we've got 2 hydrogen atoms. Here, H, there's 2. And we've got oxygen, and we've got 1 oxygen atom. In our periodic table of elements, hydrogen has an atomic mass of about 1.01. Again, we're going to round it just because we don't want to have to write all of those annoying little decimals. And oxygen, it's got a mass of around 16 grams per mole. So when we add those numbers together, we should get 18.02 grams per mole as the molar mass of H2O. Cool. Just going to write it down there just so that we don't forget it. All right, so now that we've got our molar mass, now we can convert moles into grams. All right, so I've got 0.804 moles of H2O, and I'm going to use my molar mass to convert moles into grams. What goes on top? What goes on bottom? The 18.02 has units of grams, and that's the unit that I want to get out of this problem. my per mole has units of moles. So the per 1 mole of H2O goes on the bottom. Then I can cancel out my moles of H2O. 0.804 times 18.02 grams of H2O is going to give me my answer, which is 14.5 grams of H2O. And we're done. We figured out the grams of H2O, converting liters to moles and then moles to grams. Now that you guys have had an opportunity to go through these examples / practice problems with me, I'm going to post a couple of practice problems on the Google Classroom page that are both 1-step and 2-step problems. I want you guys to try those practice problems before doing the assessment. I'll post the practice problems on Wednesday, right when I post this video on the Edpuzzle site. I'll post the assessment on Thursday. Friday is a flex day, a makeup day if you will. So what I will do is I will make the assignment due Thursday morning. But if you don't finish it until Friday morning, that's okay. With the assessment, I will make that technically due Friday morning. But again, if you don't get to it until Saturday morning, that's okay. We're using Friday as a flex day to catch up on missing work. And if you're caught up on your missing work and you want to spend a little bit more time practicing, that's okay. But if you would prefer to get this done quickly, feel free to work at that pace and get it done so that you've got an extra long weekend. I'll still have my office hours on Wednesday and Thursday from 2 o'clock to 3 o'clock, so feel free to join me if you have any questions, or shoot me an email, or message me in Google Hangouts, or call my school phone. I'll talk to you guys later. Bye.